sir.
Good afternoon, sir.
Afternoon. Um, so in the morning class, we have solved two problems based on the first law of thermodynamics. So I hope that all of you have understood the concept behind first law of thermodynamics. So this can be applied on a complete cycle or for any particular process. So in the morning lecture, so we have used this first law in process. So in this lecture also, so we'll be solving one problem. Okay, so I want to share my screen. So in the same PDF file, so the problem is there, and that file is uploaded in the Google Classroom, so you can have the access. You can see at any time, and you will be able to see it. And I want all of you please go through the problem and try to solve it yourself. Okay, now I am just showing you another problem, and I will tell you the concept how to solve that one. So this is also a problem which is based on first law of thermodynamics. So here the internal energy of a certain substance is given by the following equation. So it is given by small u equals to 3.56 small p into small v plus 84. So where 2 is given in kilojoule per kg, P is in kilopascal, and V is in meter cube per kg. That means what? One equation for what is U? This is internal energy, but it is letter small letter. So that means this is specific internal energy. Okay. For energy, we will be using the term capital E, but for internal energy, we will be using the term capital U. But here it is specific internal energy. That is why this equation is given by small u. So is equal to 3.56 p pressure multiplied by specific volume V, specific volume. Capital V is volume, small v is specific volume, plus 84. Okay, so P is given as pressure, U is given as kilojoule per kg. So why it is kilojoule per kg? Because it is specific internal energy. That is why in the unit, the kilojoule per kg term is there. So here also in volume, specific volume, per kg term is there. Okay, basically the unit of volume is meter cube, centimeter cube, like that. But here it is written as meter cube per kg because it is specific volume. Small v is used. Okay. Now, a system composed of 3 kg of this substance, mass is given 3 kg, expands from an initial pressure of 500 kilopascal and a volume of 0.22 meter cube. So initial state of the system is given. So the mass is 3 kg, initial pressure is 500 kilopascal and a volume of 0.22 meter cube. So P1 is also given, V1 is also given. Pascal. Pascal is what? 1 Pascal equals to 1 meter square per what? Newton per meter square. 1 Pascal equals to 1 Newton per meter square. Okay. So P1, V1 is given, and P2 is given volume is not given, but it is said that the pressure and volume, they are related by this formula PV to the power 1.2 equals to constant. P1 is given, P2 is V2 is V1 is given, P2 is given, but V2 is not given. But it is said that the pressure is related to the volume by this expression PV to the power 1.2 equals to constant. Okay. So what we need to find out, if the expansion is quasi-static, find total heat delta U, change in internal energy, and work done for the process. Means all these terms related to the first law, isn't it? So we are going to find out all these things by these given conditions, this equation and these parameters and this equation. Okay, so two equations are given and these data are given. Okay, P1 is given, P1 is given, P2 is given, but V2 is not given. Instead of V2, one relation is given. So from that we will be finding out the said parameters Q, delta U and W. Okay, so what we will be writing, so U is given as what, 3.56 PV plus 84. So what will be U1? So U1 will be what, 3.56 P1 V1 plus 84. And what is U2? U2 will be 3.56 P2 V2 plus 84, isn't it? So if 1 will be written here also, we need to write the suffix 1 1. So if U2 is written, so P1 P2 we have to write, then V2 we have to write in the equation, isn't it? Because this is general equation, it is the internal energy. Okay, so now we should know the difference, because what is delta U? Delta U is U2 minus U1, state 1 and state 2. In the system, there are two states, state 1 and state 2. In state 1, properties are P1 V1. In state 2, properties are P2 V2. Okay, so delta U will be U2 minus U1. So what is U2 minus U1? So U2 is what? 3.56 P2 V2. U1 is what? 3.56 P1 V1. So if you just subtract it, 84 minus 84, it will be cancelled out. Only 3.56, this expression will be left. 3.56 P2 V2 minus P1 V1. Okay. So delta U will be how much? So 3.56 it is given. P2 V2. P2 is given, V2 is not given. So P1 V1. So now how to find out this V2? Okay, how to find out this V2? So the relation between pressure and volume is given as P to the power 1.2 equals to constant. Means P1 V1 to the power 1.2 equals to P2 V to the power 1 by 2. So P1 V1 to the power 1 by 2 equals to P2 V to the power 1 by 2, because this is constant. So this multiplication will be constant for any pressure and volume. Okay, so V2 will be how much? V P1 by P2 upon 1 by 1.2. So V is given, means V1 is given. This is V1, not V. P1 is given 0.2. So 5 by 1. P1 is given as 5. P2 is given as 1. Okay. So 1 by 1.2. Ultimately, you will get the volume in the second step after calculation, and its unit will be meter cube, because this is capital V. This is volume, not specific volume. If it is specific volume, so it should be denoted by small p. So capital V2 we will get, it is 0.845 meter cube. So now you will be able to find out the volume. Okay, or you will be able to find out the change in internal energy. So here we will be putting, so P2 it is given, P2 we have found out from this formula, and P1 is given, P1 is given. So ultimately you will get minus 91 kilojoule. Means there will be a decrease in internal energy at the final step. Okay, now what you are asked to find out in another process, yeah, Q and W also you need to find out, isn't it? So the W, how you will be finding out, because the volume is changing. Okay, and the relation is given by PV to the power 1 by 2 equals to constant. Means one process where pressure and volume relates by this formula. So you have already come across that PV to the power n equals to constant is the equation for polytropic process. And what is the work done for polytropic process? So for polytropic process, in the last class we have seen that p v to the power n equals to constant. So here also it is that p v to the power p to the power 1 by 1.2. Okay, so this type of expression it is there. So you can relate it to p1 pv to the power n equals to constant, means this is polytropic process. So for polytropic process, what is the work done? So w1 to 2 will be equals to p1 v1 minus p2 v2 divided by n minus 1. Okay, so this is the expression, or this is the general form. You can take this one because this will help you in solving the problems, and it would be easier for you to commit to the memory. Okay, so p1 v1 minus p2 v2 upon n minus 1. Understood? So this, in this formula we'll be putting it uh, here in this equation. So P dV work will be equals to P2 V2 minus P1 V1 by 1 minus n. Actually, in the formula P1 V1 minus P2 V2 divided by n minus 1, but here this is written first. That is why 1 minus n it is written. But in the earlier formula, see, you can see n minus 1, P1 V1, small term is written first. Second term is, this term is written as second part. Okay. So P1 V1 minus P2 V2 divided by n minus 1 is equals to P2 V2 minus P1 V1 divided by 1 minus n, isn't it? So that thing it is written. This is written. So after putting the value of each of the term, so you will get what? The total work done. Okay, total work done. Then how you will be finding out the value of heat transfer? That will be how much? Delta U plus W, because I have told you that delta E stands for the change in energy. But here, as because we are concerning upon delta U, so Q equals to delta U plus W. Okay, so delta U will be the change in the internal energy, and it is already given as how much? 0.9 minus 991. Okay, minus 91 kilojoule. It is found out to be minus 91 kilojoule. Plus, what is the work done? Work done is 127.5. Means what? This is positive. Means what? Work is done from the system. Work is done by the system. Okay, that is why it is positive. So after that, you will be able to find out the total heat, 36.5 kilojoule. Okay. So in B, what it is as in another process, the same system expands according to the same pressure volume relationship as in and form the same initial state to the same final state, but the heat transfer in this case is 30 kilojoule. Find the work transfer for this process. Okay, so you can do it easily because already it is already covered. Okay, so Q value it will be 30, and delta U value it is already we have found out minus 91. So if you just put it in the first law of thermodynamics, so you will get the value of W. Okay, and similarly explain the difference in work transfer in parts A and B. Okay, so in parts A and B, this integration PdV will not be equal because because for this find the work transfer for this process. Okay, because this is yeah, this is not a quasi-static process. Okay, in B, this is not a quasi-static process. In another process, the same system expand according to the same pressure volume relationship, and from the same initial state to the same final state is imparted. But the heat transfer in this case is 30 kilojoule. Okay, so it's because this process is not quasi-static process, so that is why. So these two work done PdV will not be equal. Okay, as that in B. Okay, so in uh, this C you need to write that way. Understood? So this is very easy actually, the first law of thermodynamics. So only you need to express the concept in any of this process. Okay, so in any of the process to use that concept, we need to simply use this same formula, Q equals to delta A plus W. Okay, and all these things will be used in between work done formula integration of PdV, okay, and expression P1 V1 minus P2 V2 n minus 1. All these things you need to take care. Okay, so I think this concept is clear to you. uh, Whatever problem we have covered till now, just you note down all the problem. Okay, first you note down the question and then try to solve it by taking one calculator. Okay, that only you will be able to grab the concept. Okay, so thank you students for listening. So we will stop here and we will be meeting in the next lecture. Okay, the last lecture I have uploaded in the Google Classroom, so you all can have the access so at any time. Okay, and if there is any
So,
doubt, yes.
so what is the syllabus for class test one?
For class test one, whatever we have covered till now, okay.
Hmm.
So till tomorrow, do you have any class? No, we don't have any class. So up to today's session, okay, up to today's lecture, your syllabus it is okay for class test one.
Okay.
Understood? Up to the application of first law of thermodynamics to the closed system. There is application of first law of thermodynamics to the open system also, flow system also. So that thing we will cover, but that things will not be asked. Those things will not be asked in the first class test. Okay.
Okay. Okay.
So thank you for listening. So now you can leave this meeting. Okay.
Sir, this
Thank
video,
you,
sir,
sir.
this
Yeah, I
recording.
have already given the PDF file, okay, in the Google Classroom, uploaded the PDF file in the Google Classroom. And one thing, I will not be telling you that I have uploaded one video, I have uploaded one PDF file like that, okay, because you need to check it regularly, because sometimes I may miss, okay. That is why it is not compulsory that I will be telling every time. Just you just look at it, okay, you will get it. Definitely, if it is recorded, I will be uploading it, okay, as soon as possible. I will try to upload. Understood?